10.3 is parametric equations, but now with calculus. Here the theorem is if a smooth curve C is given by x equals f of t and y equals g of t, then the slope of C at x comma y is dy dx. But since we're given it in terms of t, will be dy dt over dx dt, where dx dt cannot be 0. So here's my first example. So I have that it says find dx dt. So remember that we need to find the derivative. So I'm going to have dx dt. So derivative of this with derivative of x with respect to t, b to t. dy dt, in this case, is going to be 2. So now we're going to put it together. So if we use this equation and put dy dt over dx dt, we are going to get negative 2 over 2t, and simplified will be negative 1 over t. Example 2 has to find dy dx and the second derivative. Okay, so let's do our first derivative first. So we get that dx dt, in this case would just be r1. And this from here, we get that dy dt is going to give us 2t plus 9. Our dy dx is going to be 2t plus 9 over 1. Simplifies to 2t plus 9. From here, we're going to take derivative of this one to get the second derivative. Sorry, my baby's crying, but that's okay. So here, derivative of this would just be 2. This question is also going to ask you for the slope of the function. From a previous or example, or from the notes, the slope, we substitute the parameter, in this case the negative 4, into my derivative. Okay, it will be into the derivative. So I'm going to put it in here. And we're negative 8 plus 9, oh, it's going to be 1. It's also going to ask about concavity. Concavity from calculus 1, put it in the second derivative. If the second derivative is positive, it's concave up. If the second derivative is negative, it's concave down. If it's 0, then it doesn't have a concavity. And it's an inflection point. But right now, we're talking about concavity. In this case, the second derivative is positive. I cannot plug in the negative 4. So in this case, it is going to be concave upward. Last one will be arc length in parametric form. Here's the equation: S equals integral from a to b of the square root of dx dt squared plus dy dt squared as well. So let's do the formula. First, let's take those derivatives. It's going to be dx dt. In this case, derivative would just be 8. dy dt, in this case, it's going to be negative 5. And then we just use the equation. S equals the integral from negative 1 to 3 of 8 squared plus negative 5 squared dt. In this case, there's no t's, right? It's just the number. Okay, so 8 squared is 64, but negative 5 squared is 25. We add, and we get the square root of 89. So we have the square root of 89. When we take the integral, we'll be the square root of 89t from -1 all the way to 3. So remember, we put the top, which we're going to be the square root of 89 times 3 minus, and then there's a square root of 89 times -1. Negative becomes a positive, so it becomes 4 square root of 9. That would be my answer. Web line is going to ask you to round, so you just get your calculator, put that in the calculator and round as many decimals as they want you to round. Okay?